Hello everyone, good morning. I'm Kumar Rajmani Bapat, and I'm a Master's in Data Analytics scholar and also graduate teaching assistant currently. Further, I have good hands-on experience in analyzing data, predictive modeling, and I am also an Oracle certified GenAI professional. So with this, my today's topic is brain-computer interface for emotional classification, and here we will be seeing on the enhanced staking model for EEG classification. So before I start, so as we know that the world is representing the greatest change in technology, and innovations have made our life faster, easier, and comfortable. But what about the overall thing? We are getting comfortable, but we don't know how it is affecting our health, or how it is affecting our emotions. So that way, that particular area remains untouched. So therefore, I have researched on this to make a model that is capable of analyzing all the human interactions as well as identifying how the each of our thought process get affected when we are thinking about something like maybe planning to go coffee shop, then maybe a shopping, and even our study works. So how our emotions get affected with that, and are they positive, are they negative, and are they neutral? So I have devised a robust model for that, and here you go. So background like BCIs, if as you heard that potential for revolutionizing human technology interface, and a crucial element for developing BCI would be ability to decode the emotions. Because if you are able to decode the emotions, then only BCI will make sense, right? Otherwise, if you don't have able to decode it properly, then there would be chances of inaccuracy in the data. Then here comes the electroencephalography. So this is a kind of process where we try to emulsify and try to get the emotions from the brain and separate them into different parts. That is like one of my friend told previously, that is clustering, but it's not exactly clustering. It's like grouping them into different thought process, like a chain of thoughts. Then comes the challenges. So early models face the challenges that are the individual variations in the emotions, then complex nature of EEG signals, because EEG signals often like have some variability, and if little bit change is there, so whole signal get affected. Like maybe a distorted signal would give another result than the other signals. Then noise and artifacts and a need for robust model. So these are the challenges that are resolved, and these are the brand frequency you can know. Like from 1 to 4, if we see, there's a deep sleep and relaxation. Like these are the states of our mind depending on the each of the EG signals. So this one are the states. Then we move on to the current challenges and area for advancements. So deep learning models like GNNs and different models have potential but often struggle with generalizability, because they are like on one specific model and they couldn't generalize. And also the accuracy for that model are really low because of its the nature that is not properly interpretable, like what is going into the process. It's already hidden with that layers. Then comes the ensemble stacking approach. That are the earlier ensemble stacking approach were there but not able to fully address some challenges that I have focused here and addressed in my research. So these are the research's gaps, and the strength we will be trying to leverage this model using the signal processing method for variability changes, artifact removal, ICA, and different independent component analysis, so that overall we can generalize our model to a wholesome. Then comes, these are the process framework I followed. So data acquisition, I have used the EG must dataset. So it's kind of headset you wear, and it's try to take your signals and then convert into a EG form datasets. And that datasets are initially in a different format, then we convert into PDF format, because PDF are good for analysis. Then we convert and fine tune that models. Next comes the feature extraction. So for that I use a T-sign visualization method. That is a frequency parameter is set, like a probability ratio, that more than 0.5 will be separating into another classes, and below 0.5 will be separating into other classes. Because of some nature that is already a variability changes, some research papers have already discussed that. So that's why I used it. And when we use this, still there are some overlapping clusters that you can see, that the emotions are getting overlapped. So we are not able to directly recognize, okay, this is the zero emotion, this is one emotion, means the positive, negative, and neutral. These are the three we have categorized as 0, 1, and 2. So some are overlapping. But when we perform the shape performations with that, then we are able to see more distinguished form of emotions that convert our overall symbols. So here's the model we just prepared. In this, we started with the hybrid ensembling model. That is the generalized set of base classifiers. So I have taken base classifier because there is nothing or one thing that could predict all the other aspects of the particular thing. That is, if we are going into, let's see, we want accuracy with the precision. So we are trying to use this ensemble stacking model. Because these are the base classifiers that are logistic regression support vector machine. Earlier MLP was used because MLP is high level model as well as it has multiple layers. So it goes into each layer and then try to predict the outcome on the basis of that. But problem with that was a computational problem, that is it takes a lot of time to work on our machine, as well as the other problem was that it's have the lag interpretability, like what is going to hidden layer we can't exactly see, and if you want to see particular outcome like okay this is affecting our result, so we are not able to see that with MLP. So that's why I have used two classifiers majorly that are standing out and coming as a meta classifier in the next one, that is a level one. So out of this classifier, based upon the accuracy and the test codes, these are the models which are standing out in our overall model implementation. So these are the models that you can generalize into any kind of VG signals.